Good morning, students. Today we are going to understand the chapter that is called as the chapter Gravitation. So let's understand the term first of all, gravitation, by its simple definition. What it says that the gravitation is the force of attraction. Gravitation is the force of attraction. It is a force of attraction between any two bodies in the universe. Okay. Like you are talking about the attraction between the sun and the moon, or you can say the attraction between the sun and the earth, or you can say the attraction between the table and the chair lying in your room, are all the examples of the gravitation, and it plays an important role in our life. Where this term gravitations come into the picture? When the Newton was sitting under the tree and the apple's head fall on his head, then he thought that why does apple come downwards, and he then start working upon it. But there are a lot of history attached to it that we are going to discuss right now. Just before that, we just understand the term. Also, what do you mean by the term of gravity? Okay, so let's understand the term gravity. The gravity is a special case. It is a special case of a gravitation if one of the attracting bodies is the earth. Then you call this gravitation to be a gravity. So let's go back into the history and understand the term gravity more beautifully. In the ancient time, if you talk about in the history, to understand the solar system and the theory behind it was very a tedious job, and it was very complicated, and many of the superstitions was also related to it. People believe that the earth is in a stationary. People believe that the earth is in a stationary and all the planets are revolving around it. But in 1500, the Polish scientist Nicolaus Copernicus comes into the picture. He said that no, Earth is not stationary. It is also revolving like other planets around the sun. That means all the planets are revolving around the sun and the sun is stationary. Okay, he said like that. But the theory and the explanation, all was given by is incomplete by him. But it given a direction to other scientists, and other scientists start working upon it. Then in 1571 and 1630, scientist Kepler coming and given the three planetary laws. But he was unable to explain it. He just quoted that three laws, but he was unable to explain that three laws. Why he was unable to explain that three laws? There was a very rich man at that time, that his name was Tycho Brahe. And just write the spelling, that was Tycho Brahe. And he spent his whole life looking at the stars, and by looking at the stars, he drew some of the maps, and at that time, the Kepler worked with him. After the death of Tycho Brahe, Kepler stolen his work, he stolen all of his maps, and visualized that map, understand that maps, and given the three laws. But he was not able to explain that three laws at that time. Then Newton's come into the picture. Okay, and he explained the very famous law that is called as a force of gravitation. Okay, and all the theory related to the force of gravitation was published in the book, which was called as a Principia or Mathematica. Right. All such things, Galileo also played a role. All of us knows the laws of inertia. Yes, all of us knows that the laws of inertia, what it states that anything, an object is in motion or any object is in rest, stays in that particular state of motion or rest unless it is compelled by any external force. This law of inertia gives some of the hints. This laws give some of the hints that why that the earth revolves around its orbit. Why? Because there is no external forces acting upon it, and any object continues to move into same velocity until unless it being compelled by an external force. So Galileo also gives some of the hints to the Newton, and the Newton's first law, second laws, third laws also explains some of the concepts of gravitation very beautifully. Now, this is some of the glimpse of the, you can say, the history of gravitation. And one more question you must be thinking, that apple comes towards the earth, right? If you push us back to the picture, that this apple falls on the earth. Why earth doesn't fall on the apple? Do you remember this formula, the second law of motion, that is force is equals to m into a, right? If I just correlate the relation between the mass and the acceleration, you can simply say that the acceleration is equals to force upon mass. Means it is inversely proportional to the mass. More the mass, less will be the acceleration. All of us knows that the mass of the apple is less. So the acceleration due to acceleration of it, which is called acceleration due to gravity, is noticeable. That's why the acceleration of the apple was visualized, and we can see the apple falls towards the earth. But the mass of the earth is very much, and the acceleration of the earth is very small. That's why it is not noticeable to us. So this was just an history related to the term gravitation, the term related to gravity, and some of the scientists worked upon it to understand the concept of gravitation. In the next session, we are going to discuss all about these things in a detail, and we are also going to derive the force of gravitation also. So take care of yourself. Thank you.